important concepts from grade 10, which is just like revising the difference between velocity and speed, revising the difference between distance and displacement, as well as explaining what acceleration is. But the good part is that in grade 12, your acceleration will always be the same. So remember, in grade 10, equations of motion were a bit challenging because it's not always the case that you have your acceleration. So in grade 10, they were more challenging than in grade 12. In grade 12, it's going to be much easy because of the acceleration is always there, and it's the acceleration due to gravity. I'm sure you guys already know the value of the acceleration due to gravity because you also did it in grade 11 under Newton's laws, right? Yeah.
Yes, sir.
Then we're gonna explain what free fall is as well as what a projectile is. So these are two different concepts, but they are closely related because a projectile is an object and free fall is a type of motion, right? So basically, just to summarize, a projectile is an object that is under free fall. So we will explain what these things are, right, during the lesson. And obviously, we're gonna use equations of motion to solve problems, right? So you already know about equations of motion from grade 10, so it's not supposed to be that much challenging, right? And also in grade 10, you were also drawing the graphs. Remember, velocity versus time, position versus time, as well as acceleration versus time. And remember, we said that in grade 12, your acceleration will always be constant because it's acceleration due to gravity. So basically, your acceleration versus time graph will always be the same, right? Will always be the same. So that should not be a problem. So the interesting graph here is the velocity time graph as well as the position time graph. Yeah. All right. So let's get started. I know some of you guys have already started with VPM on your own. So you will help me today. Yeah. All right. So this is an extract from the examination guideline. So this is all that you need to know, right? Based on the examination guideline. Like I said, you need to be able to explain what a projectile is. So here they are explaining it. You need to be able to explain what free fall is. As you can see here on the examination guideline, they say that a projectile is an object, whereas free fall is a type of motion, right? So please be able to differentiate between the two. Then we're gonna have to be able to use equations of motion, right? Equations of motion to calculate different variables, right? But then acceleration won't be one of the variables because it will always be given as 9.8 meters per second squared down. Yes, Blessing? I can see your hand is up. Or was that a mistake? Slindile, I see your hand is up.
The acceleration is always 9.8 on BPM.
Yes, it's always 9.8, and we will explain why it's always 9.8. Yeah? We will explain why it's always 9.8. Then you should be able to plot the graphs, like I said. You should be able to plot a graph of these scenarios, right? So they are mentioned here. So you need to be able to plot graphs for these scenarios. So today we won't do like bouncing objects as well as hot air balloons. We'll just focus on problems where a ball just moves along a path without even bouncing, and it's not moving. It's not in a hot air balloon or in a flight or anything. It's just a ball or a stone that has been thrown upwards, right? It's just a simple problem that we're going to be dealing with today. Then tomorrow we will cover bouncing objects as well as hot air balloons if time allows. Yeah. All right. So intro to vertical projectile motion. So as the word already suggests, right? So the motion that we are dealing with here, it's motion in the y dimension, right? So remember, we have the x dimension, which is horizontal motion, as well as the y dimension, which is the vertical dimension. So now the motion that we're going to be dealing with in grade 12, it's vertical, right? So the objects are going to be moving either up or down, right? You won't get a problem where an object is moving horizontally. So if you do get an object that is moving horizontally, they would expect you to be able to solve it because you've already done it in grade 10. But then they would just be integrating it. I'll show you a problem whereby they just bring in an object that is moving horizontally. Yeah? But most of the time, the objects are moving up or down. Yeah? Then a projectile, right? So a projectile is basically an object under free fall, an object that is under free fall. But then what is free fall, right? So free fall, guys, it's a type of motion whereby there are no other forces acting on the object except gravity, right? So free fall, when we say that an object is under free fall, it means that gravity is the only force acting on that object, right? So a projectile is basically an object under free fall, right? So just to summarize, vertical projectile motion, we will be dealing with objects that are moving up or down, and it's only the force of gravity that is acting on that object, right? So at times you find that the object has been given an initial velocity by just throwing it, yeah, by just throwing it. Thereafter it continues moving under the influence of the force of gravity only. Does that make sense, guys? Do you have any questions so far?
Yes.
All right, so here
Uh,
are the
Sorry to disturb you, sir. So, sir, if
yeah.
someone drops an object from a building, so the velocity of the dropping object, that's the initial velocity.
So when we will talk about that, but just to answer you because I see already ahead, when an object is dropped, basically the velocity of the throw is zero. It was
Mm-hmm.
not thrown, it was released, right? So its initial velocity would then be zero.
Okay. 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 Thank you.
Yeah. All right. So now here are the equations of motion, guys, from grade 10. You're already familiar with these, right? So I want you guys to notice that there are only 5 variables here, right? So the variables that we have, it's V initial, right? Which is the initial velocity, right? The initial velocity, which is in meters per second, right? Then we also have VF, right? VF is the final velocity, right? Final velocity in meters per second as well. Then we have acceleration, which is A for acceleration, and the units are meters per second squared, right? And in this topic, like I said, the value would always be 9,8 meters per second squared, and the direction is down. Remember, these are vectors, right? So let me indicate here that this is a vector, right? This is a vector. This is a vector as well as acceleration is a vector. Let me just indicate here that it's a vector. So remember, we said that with vectors, we always need to take the direction into consideration. Yeah? Then we have time, change in time, which is the time traveled, or time taken to travel between 2 points, right? Then we have change in y, right? So here, guys, it's very important to understand that change in y is not distance. Yeah? Change in y is displacement, and it is a vector, right? I know that there's this misconception of saying that change in y is distance. It's not. Distance and displacement, they are closely related concepts, but they are not the same, right? So if you think that this thing here is distance, please wipe that thinking, and just know that this is displacement and it's a vector. So if it's a vector, we also need to consider its direction, meaning that we can substitute it as negative into a formula, right? Whereas distance is a scalar, it's always positive, right? Change in y can be negative. I'm saying this because of you'll see as we solve the problems, there are times whereby the value of change in y would be negative, and you'd start being scared and asking yourself, why is my distance negative? This is because it's not distance, it's displacement, it's a vector, it can be negative, right? But then at times the displacement of an object is the same as the distance of the object, but not always. Not always. Ne? Are we all on the same page, guys? I will teach you how to use these formulas.
Yes.
Right? So the units of distance displacement, obviously it's in meters. Let me write it down there. It's in meters. Then our time is in seconds. This is also a vector. So as you can see here on these formulas, our only scalar quantity is time. Time is the only scalar quantity, which means that it always has to be positive, right, when we substitute it into the formulas. But others, they can either be positive or negative, depending on the scenario. Yeah? All right, let's pass. Yeah? So now let's revise some important concepts from grade 10. So remember, I told you that you need to know the difference between distance and displacement. So it's simple. Distance is basically the total path that you have traveled, right? So you add all the
Sir,
yes.
may you please go back so I can take a picture of the formulas?
I will send this document, and also it's not necessary for you to memorize the formulas because they will always be given to you on your formula sheet, but you can screenshot them if you want to just write them down in your book and also write the units.
Okay, thank you, sir.
So please don't memorize the formulas, guys. There are important things that you need to memorize. Even myself, I don't know the formulas by head because they are always given in the formula sheet. Yeah. So, like I said, guys, distance is the total path that an object has traveled. And another thing, distance is a scalar. It's not the same as displacement because distance is a scalar, whereas displacement, it's a vector quantity, right? So just to remind you guys, hey, maybe you might have forgotten, right? When we say that it's a scalar, we mean that it has magnitude only. It has magnitude only. What is magnitude? Magnitude is size, right? So whenever we give the value of a scalar, we only give its size only. We don't care about the direction. For example, mass of an object. We can't say that an object is 10 kg up. That does not make sense, right? So we always give the size of the object only without even including the direction. Whereas with vector quantities, they have both the size and the direction. Example is displacement, right? So when an object is displaced, we want to know where exactly has it been displaced. Has it been displaced to the right? Has it been displaced upwards? So we need to mention those things as well, right? So as you can see here, there's a illustration of the difference between distance and displacement. So distance, right? So let's say you are here at your home and this is your friend's house. You travel via this blue path to get to your friend's house. So this blue path that you traveled, the exact path that you followed would actually be your distance, right? But your displacement would then be the line drawn, the straight line drawn between your initial position and your final position, right? So just to summarize it, displacement does not care about what was happening in between, right? It only cares about where your object started and where it ended. Only. The other things that were happening in between, displacement does not care about that. It's only concerned about where you start and where you finish. So that's displacement, and it's a vector. So whenever you give the direction of the displacement, you look at where did the object go, right? So if let's say you are the object, you started here, right, and you traveled in that direction, so the displacement would actually be the direction in which you traveled, right? So you were displaced to the right. You were displaced to the right. You started here, then you moved to the right. So basically we would say you were displaced to the right, right? So even if maybe you have an object starting on the ground, you throw it up, then it gets caught maybe at the top of a certain building there, right? So we would say that this object was displaced upwards, right? But we also need to mention the magnitude of the displacement. How many meters upward was it displaced, right? So you'd maybe be saying it was displaced 10 meters up, right? So that would be your displacement. It's a vector. And you already know distance, guys. I think the distance is the most simplest concept, right? But then at times, the distance of an object would be the same as the displacement of the object, not always. So let me give you an example where the displacement and the distance are the same. So let's say the person, this path, instead of following this path, they walk along this path, right? So if they walk along this path, you see that then now the displacement and the distance would be the same thing, right? There wouldn't be a difference in magnitude. They would be the same. The only difference is that when we give off the displacement, we would have to mention the direction as well, right? Does that make sense, guys? And you will see the importance of this when we do VPM, right? Please make it a point that you understand the difference. And if you have any question, please let me know before we pass. This is very fundamental, guys. Very, very important. All right, so we can pass now. Then the difference between scalar and, the difference between speed and velocity, right? So remember, speed is a scalar, velocity is a vector, right? So speed is basically saying the distance divided by the time. Okay, I want to make a disclaimer that this formula is for when you calculate the average speed. Yeah, average speed and not instantaneous speed. And as well as this one, it's also for the average velocity, right? So just to summarize the difference, basically like speed is the measure of how fast you change distance, right? How fast does your distance change? Whereas velocity is how fast your position changes, right? How fast are you displaced, right? There are two related concepts, but they're not the same, right? It's not always the case that the speed of an object will always be the same as its velocity. Okay, it's not the same that the average speed of an object is the same as the average velocity. But instantaneous velocity of an object would be the same as the instantaneous speed of an object, but the averages would not be the same. Let me give you an example of a treadmill, right? So when you're on a treadmill, the machine registers your speed, right? It registers your speed because of now even if you are not moving, you're on the same spot, you still cover a distance, but then now your position is not changing. Basically your velocity is going to be zero because you're not displaced. Your velocity is zero, but then you do have a speed. Do you guys see that velocity and speed, they can be different? It's not always the case that they're the same. That there are situations where they're different. Do you guys get it?
Yes, sir.
Yes, sir.
So
Yes, sir.
speed looks at how fast you change distance. As you can see, it's distance over time, whereas velocity looks at how fast you are displaced or how fast your position changes. So it's changing position over changing time, right? So they are closely related but not the same. Yeah? But then instantaneous velocity of an object and instantaneous speed at the same point, they would be the same. They would have the same magnitude, but the averages might differ because of the object's velocity and the object's over. But again, the object's distance and the object's displacement, they might differ, right? Therefore, the speed would differ from the velocity. Yeah? So it's just like some things that you need to know before we actually start with the calculations. All right, so acceleration, we can't relate it to any other concept, which we're just going to study it alone, right? So acceleration is basically the rate of change in velocity, right? So basically it's the measure of how fast an object is speeding up or how slow, a measure of how fast it's speeding up or how fast it's slowing down, right? So how its velocity changes, right? So basically acceleration is measuring whether your object is slowing up, speeding up, slowing down or speeding up. Yeah? So that's acceleration, right? How you increase your speed, right, with time. Yeah? It's acceleration and it's measured in meters per second, right? So here are the units for acceleration, meters per second. But then now under VPM, our value for acceleration would always be 9,8. Do you guys want us to prove it? We can prove it why it's always 9,8. Remember in grade 11, you did a law of universal gravitation where it says that every object attracts every other object with a gravitational force, right? That is directly proportional to the product of the masses, but inversely proportional to the square of the distance between the objects, right? Or between their centers, right? So the formula says that the force of gravity is equals to G multiplied by the mass of the object multiplied by the mass of another object, M1, M2 over R squared, right? So now let's take a look at an object and Earth, right? So any object and Earth, right? So this object is on the surface of Earth, right? So basically the distance between the object and the center of the Earth would basically be the radius of the Earth. Do you guys get it? If the object is basically on the surface, right? So we already know that R here would be radius of Earth, and one of the masses would actually be mass of Earth, right? And the other mass would be the mass of any object. I can call it M, right? But then also Fg is equals to mg, right? Fg is equals to mg, right? So m multiplied by g, right? Where g is the gravitational acceleration. So mg is equals to gm multiplied by me over re. But then look, this is basically the mass of the object, right? The small letter m is the mass of the object. And also here we have that small letter m is the mass of the object. So basically they can cancel each other out like that. Then we would have that g, or gravitational acceleration, is equals to capital letter G me over re, the radius of the Earth, right? We have the mass of the Earth. Here's the mass of the Earth in kilograms. And we also have the radius of the Earth in meters, right? So basically G would be equals to, do you remember the value of this capital letter G? It's also a constant. It's 6 comma something. Do you guys remember it? I did not include it here. 6,67.
7 times 10 to the negative 11.
To the negative 11, right? So now let's substitute and see. 6,67 times 10 to the negative 11. Remember, this is squared, right? R squared. The distance must be squared. Multiplied by the mass of the Earth is 5,98 times 10 to the power 24 all over RE, which is 6,38 times 10 to the power 6. Then I'm going to square this. Right? Put this in your calculator. It should give you 9,8 when you round it off. So let's see. 6,67 times 10 to the negative 11 multiplied by 5,98 times 10 to the power 24. Then we have 6,38 times 10 to the power 6 all squared, right? So as you can see, the value is 9,7999, right? So which has to give us 9,8 meters per second squared, right? So G is the acceleration, right? G is the gravitational acceleration, and it will be 9,8, right? For any object on the surface of Earth or near the surface of Earth, it will always be 9,8. But this is only when the net force is the force of gravity, right? Because of if there's any other force acting on the object, then our net force is not gravity, right? So you can't use the acceleration as 9,8 because remember, F net equals to ma, right? F net equals to ma, and we can only use this only if our F net is actually Fg, right? Only if our F net is Fg. But then if there's any other force involved, then our acceleration, remember F net is equals to ma, right? So if Fg is the only force, right? If Fg is the only force, then we would have that, okay, mg is equals to ma, then the masses will cancel each other out, then our acceleration would be g, right? So as you can see, your acceleration would be g only and only if F net is the gravity, right? So if F net is the gravity, it means that the only force is the force of gravity, right? So the acceleration of an object can only be equals to g, which is 9,8, only and only if the only force is the force of gravity. If there's any other force, it won't work, right? So therefore, under vertical projectile motion, we need to ignore air resistance, right? But in reality, guys, you can't ignore air resistance. In reality, air resistance would always be there, right? So it's only in a vacuum where you can have no friction. But then other than that, friction would always be there, whether you like it or not. But then here we're just assuming that friction is not there. Are we all on the same page?
Yes, sir.
Yes.
Yes, we are enjoying the class.
That's fine.
Yeah, enjoy. All right,
Yes.
so before we start with the equations of motion, the important terminologies that I want you guys to understand. When they tell you that an object is starting at rest, or when they say that an object is starting at rest, or they can also use the word stationary. you can say that the object is stationary or starting at rest. It means that the initial velocity is 0, right? They can also use words like the object has been dropped. When an object is dropped, also the initial velocity where it starts is 0, right? They can also use words like the object has been released. Yeah? Released, the initial velocity is 0, right? So starting from stationary, starting from rest, the object is released, the object is dropped. They all mean that the initial velocity is 0, right? Then when they tell you that an object comes to a stop or the object stops, they simply mean that the final velocity is 0. VF is 0. Remember, initial velocity is VI. Then final velocity is VF, right? So if they tell you that an object comes to a stop, it means that the final velocity is 0. Right. Okay, then now I have a question for you guys. What is the difference between negative acceleration and slowing down? Are these things the same? Mhm. When they tell you that when you calculate an object's acceleration and you find it to be negative, does it mean that the object is slowing down?
I think
Yes,
it
sir.
goes the other direction.
Hmm? I heard someone talking about direction. What about the direction? Hello?
I'm sorry, sir, that is me. I think I'm wrong.
Okay, I didn't hear you. Please repeat what you said about the direction. Maybe you are right.
Oh, I said that when it's negative, it means that it is going the other direction.
It means that the object is moving in the other direction. Yes, so I see through your hand up. Yes.
I think when it's negative, it's at 0. It's at rest. It's not moving. And when it's decreasing,
no, that's incorrect. No, that's incorrect. Okay, guys. Okay, let's give others a chance. Yes, Tando.
So doesn't negative acceleration mean that you have changed your direction? Like if you were going a certain direction and then you find your acceleration to be negative, you're now going in the opposite direction.
That what you're saying is true, but it's for velocity. Negative velocity means that you've changed your direction, the direction in which you are moving. It's not true for acceleration.
Okay, thank you.
All right. Yes, Ernest.
So does it mean that there's a change of position of the object?
Yes, if the object is moving, yes, there is a change in position, but that does not answer the question.
Yes. Okay. Okay, so
Okay, Blessing.
say I do agree with you. When an object has a negative acceleration, it means that the object is slowing down. I do agree with you.
No, that's not true.
Can I have a reason?
All right, so now let's explain it. Yeah? I'm putting it this here because it's one of the misconceptions that a lot of students have. Even myself, when I was in grade 10, I only understood the difference when I was in grade 12. Yeah? So the reason is when we say that an object has a negative acceleration, that solely depends on the direction we choose as positive. Remember, the direction of an object's acceleration is in the direction of the net force. Do you all agree? Please give me thumbs up if you agree that the direction of an object's acceleration is in the direction of the net force. Always, right? So now remember in VPM, the
Sir,
net force is gravity. Yes?
sorry, sir. Can you please explain why what you said before? Sorry to disturb you.
I said that the direction of the object's acceleration is in the direction of the net force. Do you agree? Etando.
Oh, sir, can I have a reason why? What's the reasoning behind that?
Remember from grade 11, we had that F net is equals to MA, and we had that the net force is directly proportional, acceleration is directly proportional to F net, right? So if the direction of F net is to the right, even the direction of acceleration would be to the right because they're directly proportional.
Okay, thank you, sir.
Right? So now that's the direction of acceleration is in the direction of the net force. But under VPM, look, the only force acting on your object is Fg, right? It's Fg only. It's only the force of gravity. So it means that our acceleration, our object is always accelerating downwards. This is the direction of the acceleration. Our object is always accelerating downwards. Whether acceleration is going to be positive or negative, it solely depends on the direction that you personally choose as positive. If I choose up as positive, this means that because now my acceleration is downwards, it means that the acceleration would be negative 9.8 meters per second, right? It means that the acceleration is negative. Now I explained the part of the negative. The negative part, it only depends on which direction you choose as positive. It does not tell you whether the object is slowing down or not. What tells us whether the object is slowing down or not? Let's explain. So now, what tells us whether an object is slowing down or not? It's the direction that the object is moving. If the object is moving in the direction of the acceleration, then the object is speeding up. If your velocity is positive as well as not if your velocity is positive as well as your acceleration is positive, then you are speeding up. If your velocity is negative as well as your acceleration is negative, you are speeding up, right? So if your acceleration and your velocity are in the same direction, you are moving in the direction of your acceleration, you are speeding up. But then now, if they are opposite, if your acceleration is down, but you are moving upward, the direction of motion is upward, then you are slowing down. Now, let's take a look at an example of a projectile. Now, when you throw an object up, use your common sense. Yeah? Use your common sense. When you throw your object up, let's say from the ground, you throw it up, then it reaches a certain height, then it starts going down again. Now I'm gonna ask you, as the object moves up, do you think it's slowing down or it's speeding up? Common sense only.
Slowing down.
It's slowing down. It's slowing down. I agree with slowing down.
Yes, sir.
Because of if it was speeding
Yes,
up,
sir.
then it means that the objects that we throw up, they would never come back if it was speeding up. Do you all agree?
Yes,
If
sir.
an object that is moving up was to speed up, it means that it was never gonna come back to the ground. For the fact that it comes back to the ground, as it goes up, it means that it's slowing down. But then now when it starts moving down, when it turns, it reaches that maximum height, it turns and it starts moving down again. Is it speeding up or is it slowing down?
It's
Speeding
speeding
up.
up.
Speeding up.
It's speeding up, right? It's speeding up now, right? So now let's use what I just told you to prove that indeed it's slowing down when it goes up. We chose up to be positive, right? We chose up to be positive and down to be negative. So for the entire motion, we know that it's only the force of gravity that is acting on the object. Remember, we said that it's a projectile, only force of gravity. It means that for the entire motion, the acceleration is always downwards. So acceleration is down. But then look at this part of the graph or of the object's path. It's going up. Its velocity is up, but then the acceleration is down. Remember, I told you that if the velocity and the acceleration, they're in different directions, it's slowing down. Can you see indeed it's slowing down?
Yes.
Same thing. I said that if your velocity and your acceleration, they are in the same direction, it means that your object is speeding up, right? So look, this object here is moving down. The velocity is downwards, right? The velocity of this object is downwards. So it's moving down. The acceleration is also down. It's speeding up. You see, that proves that when the acceleration and the velocity are in the same direction, then it means that it's speeding up. Then when they're in opposite directions, it means that it's slowing down. I can change things and say that I choose, remember that the positive direction is your choice. I can say that I choose down to be positive now. I choose down to be positive, then it means that my acceleration would be positive because remember F net is downwards. So if down is positive, then my acceleration would be positive, right? It would still give me the same, I would still end up at the same conclusion. When the object is going up like that, its velocity is going to be negative due to the direction that I chose, right? So remember, up is negative, as well as now the acceleration would be positive. So you see that now the object's velocity and the acceleration, they're in opposite signs. They have opposite signs. So it therefore concludes that, okay, it's slowing down. But then now on this side of the graph, the object is going down. The velocity is positive because the object is moving downwards. But then the acceleration is still downwards. Both the acceleration and the velocity are positive. If they are both positive, it means that the object is speeding up at that point. Does it make sense, guys?
Yes.
Yes.
So positive
Thanks.
acceleration, negative.
I'm disappearing for now.
All right.
Lebogang,
All
thanks
right.
for
Thank you.
disappearing. I learned a lot.
Okay, Arne, thank you, sir. Thank you for being with us.
Sharp, sharp.
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 So, Blessing, I see your hand is still up.
I'm sorry, sir. I wasn't aware.
Okay. Hey, Blessing, I want to ask you a question. Where are you from? Hey, Blessing, I have a question for you. Is your other name Tiset? Yeah, Blessing. You are muted if maybe you are speaking.
It's Onalena, sir. It's not me.
Okay. No, Blessing. I wanted to ask you, is your other name Tiset? Or your other name is Onalena?
No, sir.
No, sir. No. No.
Oh, okay, no problem. There's this other learner called Tisetso that I'm looking for. No, not the Tisetso Wangwanyana, but the boy. Okay, but the story for another day. So Ralph, you see that negative acceleration and slowing down, there's no correlation between the two. Yes, Onalena. There's no
Sir,
correlation.
I think the confusion for me is that the slowing down part, or the acceleration is going up, the velocity is going down. I don't understand that part. When it's speeding down, when we choose like positive as down, I understand that part. Or it's gonna accelerate. The other side,
So you meaning to tell me that your choice of direction would influence whether the object is accelerating or not?
yes, sir, I want to understand that part.
How is it gonna influence it? No, let's remove the physics, the maths, and everything. If you throw an object up as it goes up, is there ever a case whereby it would slow down, or sorry, where it would speed up while going up?
No.
So how would the direction that you chose then influence that? So now when I in the books, the direction that you choose, how would it influence that? It has no interference with that. If the object is moving up, it will always be slowing down. That is standard. It won't change. Whether you choose up as positive, whether you choose up as positive or up as negative, it will always be slowing down.
Okay, sir. The part that I want to understand, it's where they are like opposing themselves, where the velocity is decreasing and the acceleration is increasing.
What do you mean by acceleration increasing? Acceleration
Going fast.
won't
Going fast.
Acceleration will never change. It will always be 9.8. It never changes. What changes is the velocity.
Only.
Yes, right. So when the velocity is increasing in magnitude, we say that the object is speeding up. The object is accelerating. So to tell whether an object is speeding up or slowing down, just look at the initial velocity, look at the final velocity. That will tell you whether the object is speeding up or slowing down. Look at the magnitudes, not the signs, right? So the signs, whether it's positive or negative, it will depend on the direction that you chose as positive, right? That won't tell you whether an object is speeding up or slowing down. For example, you're gonna throw an object here at a certain velocity. Maybe you throw it at 5 meters per second. When it reaches this maximum height here, where it turns, always its velocity is gonna be 0 meters per second, right? So let's say I chose, remember my choice now, up is positive, right? Or let's choose up to be negative. So this 5 meters per second here, it's gonna be negative, right? But then to tell whether this object is slowing down or speeding up as it moves from here to here, I don't need to look at the sign of this -5. I need to look at the magnitude. It moved from a magnitude of 5 to a magnitude of 0, means that it's slowing down.
Okay, so you answered my question.
Right?
Thank you.
So the negative, it just tells you the direction, and the negative, it only depends on what we chose as positive when we do the calculations. Because I can change this and say that I choose up to be positive. Then now this 5 now becomes positive. But still, even if it's positive, I don't care about it. I'm going to look at the magnitude. The magnitude changed from 5 to 0. It means that it's slowing down still. So whether I choose up as positive or up as negative, it does not change the fact that this object is slowing down as it moves up.
Okay, sir. Thank you.
So,
All
sir,
right. Yes.
let's say what speed up, yeah.
Yes.
Yeah, you did mention what we ignore like the wind one,
Sign.
but The wind,
Oh yeah, the air friction.
yeah, the air friction. So,
Mm.
real life situation, I throw a ball upwards there. Obvious, the air friction is gonna act. So, does that affect the velocity?
Yes, it's gonna affect a lot of things. It's gonna affect the acceleration. It's gonna affect the speed of the object.
Hmm.
If there is air friction, yes, it is gonna do that.
So, like, if I does it still remain the same as if I throw it up, it's still slowing down, and then when it comes down, it's speeding up. Does that factor
Yes,
work?
yes, it's still gonna be the same thing because now remember gravity at the end of the day is gonna win,
Oh, yes, sir. Okay.
right? The net
Mhm.
force would still be downwards either way. Gravity is still gonna win over air resistance.
Oh, okay. Thank you, sir.
All right, no problem. All right, guys, let's pass here, yeah? And now talk about free fall and what a projectile is, right? So free fall, as we mentioned, I think I've already introduced to you guys what vertical projectile is. You already now have an idea. So free fall, it's a motion, type of motion where the only force is gravity, right? A projectile now is an object that undergoes free fall. That's how I can summarize it, right? So a projectile is an object that has been given an initial velocity, then it moves under the influence of gravity only. So basically, they're saying that a projectile can also be an object that you just throw, then leave it for gravity to act on it, right? So it does not mean that a projectile will always be objects that are dropped. Even an object that you throw up, it's still a projectile, right? An object that you throw down, then leave it for gravity to be the only force acting, it's still a projectile. But then in summary, free fall type of motion. Projectile is the object that undergoes free fall, right? So let's pass there. Please make sure that you do know the definitions and take them exactly from the examination guideline. All right. So these are the steps by me, right? I try to make you guys your life easy, right? By just giving you steps, general steps of how to solve vertical projectile motion problems, right? So basically what you're gonna do is you're gonna draw a parabola showing the motion of an object. So just to draw a rough sketch as to how the object was moving, right? It's always gonna be a parabola either way, right? So this type of graph, we call it a position versus time graph, but you wouldn't be drawing a perfect one because if the question didn't ask you to draw it, you didn't want to draw a perfect one. You're just gonna draw a rough sketch so that you can be able to solve the problem. Draw a rough sketch of a position versus time graph, right? So then what you do is you're gonna label different parts of the graph using letters. Sometimes you can use numbers, right? I will show you what I mean, right? Then at different numbers or at different letters of that motion, if you have the velocities, indicate them on your rough sketch. Just put in information on your sketch. Just like in Euclidean geometry, you always put in information on your sketch. So do that. Put in the velocities that you have at different points. But then another important thing that I know is that at the maximum height, né? At the maximum height, the velocity is zero always, right? So at the maximum height, the velocity is 0 meters per second always. This is because now at the maximum height, that's where the object then changes direction from moving upward to then moving down. Whenever an object changes direction, it has to stop first. Remember, we are not at spin city here, right? You need to stop, then turn, right? So every object that changes direction or where there's a change in direction, you need to stop first. That is why at the maximum height, where the object changes direction, the velocity is zero. And it's just a pity that you haven't done calculus in maths. I was also gonna show you the mathematical way of interpreting it. Yeah? of the mathematical reason as to why at the maximum height the velocity is 0. No? But I'll just give you a brief summary, give you a step ahead into calculus. All right, so then you're gonna have to, before any calculation, guys, under momentum and impulse, we were choosing the positive direction, right? Choose your positive direction. So your choice of your positive direction, you need to stick to it. Because if you choose your positive direction to be up, remember, the acceleration under this topic, it's always acceleration due to gravity, which is down. So it means that your acceleration would be negative 9,8, and you're gonna have to stick to that throughout the entire calculation or the entire problem. Then if you choose down to be positive, then your acceleration would be positive, and you're gonna have to stick to that for the entire problem, right? But my advice, what makes sense to me and most other teachers, choosing upward works, right? I'm going, so for the entire lesson, we're gonna choose upward as positive. Then at the end, where I see that you understand, I will just show you what happens when you choose down as positive, because of now the graphs would be different. Your velocity versus time graph, your position versus time graph, your acceleration versus time graph would look different based on the direction that you chose as positive, right? So we're gonna choose up as positive, because why? When we choose up as positive, the position versus time graph, it looks nice, and it kind of like just gives you an image as to how the graph or how the object was moving. But if you choose down as positive, your position time graph looks nothing like the path that the object followed. So that's why I don't like it. But then I'm gonna teach you choosing up as positive. Then choosing down as positive, I will show you how to convert between the two. Do you guys do reflections in maths, reflecting across the x-axis, reflecting across the y-axis? So basically, if you choose up as positive, then you draw the graph. Then you want to convert it to a graph where down is positive. Simply reflect that graph across the x-axis. So that's how I used to do it in high school. I was always able to draw graphs where I chose up as positive. But then now when they started to want a graph where down is positive, I would simply draw my graph as up as positive, then reflect it across the x-axis. Still get the same answer. Now, all right, so now whenever you have a problem, right? Remember, we labeled the parts of the graph A, B, C, or D, A, B, C, and D, right? So you need to choose two letters that you're gonna use to solve a particular problem. And I'm gonna show you what I mean by that. Yeah? Then once you've done that, you record the information that you have about the 2 points. So now in this topic, let's go back to the formula. Let's go back to the formulas. So here are the formulas, you see them, right? So we have 5 variables. So to solve a problem relating 2 points on a projectile's path, you need 3 variables about those 2 points, at least 3. But then in this case, you would always be having the acceleration about those 2 points. So you're gonna need 2 more variables so that you can be able to solve a problem. All of these equations, they have 4 variables in them, right? So basically, remember, if you want to solve an equation, you need 1 unknown variable. That is why I'm saying that for you to solve any problem, you need 3 known variables and 1 unknown. But then acceleration is always known. So basically, you need 2 more known variables and 1 unknown. So whenever you pick a formula, you're gonna pick a formula with 3 of the variables that in those 3 variables, they include acceleration. You're gonna choose a formula with 3 variables that you know and 1 of the variables that you don't know, right? then you choose it from here, right? You choose it from here. That is why it's important to always record the data that you have, right, before you solve the problem, so that you see which variables you have and what unknown variable you don't have, right? Then what you're gonna do once you've indicated the variables that you have and what you don't have, you're gonna substitute them into the formula that you chose. Then when you substitute into the formula, guys, please don't manipulate it first. Remember, this has been a rule from grade 10. Even today, it still holds. Yeah? Don't manipulate the formula first. Substitute first, then manipulate to find your answer. Write your final answer with correct SI unit. Remember, we don't mark the manipulation part. That's maths. So they will mark that in maths. We don't do that. We just want your formula, your substitution, the final answer. But either way, you won't get to the final answer without manipulating, right? So bad we won't mark the manipulation because it's maths, right? We can't be testing maths knowledge under physics, right? We are only concerned about the physics, right? So please make it a point that you are very good with your algebraic skills, how to make variables the subject of the formula. Very important. You need to know that skill. You need to have that skill. Be able to solve quadratic equations, be able to solve linear equations, exponential equations, because we do all of them here in physics. But you will do that for free, no marks, because that's maths. Right? So now I want you guys to understand the path of a projectile, right? So the path of a projectile is represented as a parabola, right? As a parabola, right? So how the position of an object changes with time, it's shown as a parabola. So suppose that an object has been projected upwards, right, has been thrown upward at 4 meters per second, then it returns to its starting point after 6 seconds, right? So now I want you to draw the parabola that indicates the motion of the stone. Or right, so let's say it was thrown from the ground, for example. Yeah. So this object would move like this. It would move up, 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 reach a maximum height, then start moving down. Right? Then start moving down like this. Okay, let me make it look properly. Right. Like that, right? So they said that the velocity here is 4 meters per second. So remember that step I told you that when you're given a problem, draw the graph that I'm talking about. It looks like this, right? Indicate the points, label the points. This is point A, the point where it was released. I can call it A. Can call this point point B. The point where it returns to its starting point, it's C. You'd notice that I'm showing this graph as a parabola. This is for explanation purpose. In reality, when you throw a stone up and if there's only gravity acting on an object, there won't be horizontal displacement. This graph is opened like this due to the time axis, right? It's opened due to the time axis because of time also moves, therefore opening this graph horizontally like this. We draw this is a position time graph. We draw it like this, but then in reality, the exact motion of the object is not like this. The object actually, it goes up, reaches a maximum height with the same position that it followed. It's gonna come back down like that. The orange indicates the object moving up, the purple indicates it moving down. It's gonna follow the same path. It won't be displaced horizontal, because why? There are no horizontal forces acting on the object. How would it be displaced horizontal? It's just gonna go up, then come back down along the same path. So basically point A and point C, it's the same point. Yeah? But then we are representing it like this for explanation purposes. Do you guys get it? But at the back of your mind, remember that the exact motion, it's straight up, then straight back down. Are we all on the same page?
Yes, sir.
All right. So now, remember, this is a parabola now, right? The velocity here, not the position, the velocity, right? So the velocity here is 4 meters per second. Remember, we said that velocity, but again, parabolas are symmetrical along what? They're symmetrical across what, guys? Functions, grade 11. The parabola, what is the axis of symmetry of a parabola?
It's the middle of the graph, sir.
The turning point, right?
Turning point, yes.
So a parabola is symmetrical across the turning point. So now, just to give you a summary, guys, velocity is the gradient of this graph. Yeah? So the velocity is the gradient of this graph. So it means that at this point A, the gradient of this graph, it's actually 4. If you were to calculate the instantaneous gradient at this point, you would get 4. You haven't done calculus, but I'm just giving you an idea, right? So now, this point and this point, they would have the same gradients, but the gradient would differ in sign, because here the gradient, as you remember, we interpret our graphs starting from the left, moving to the right. Ne? We start from the left, moving to the right. So as we move from point A to point B, the graph is increasing. So our gradient is positive, right? Our gradient is positive. And this side, the gradient would be negative, right? At this side, the gradient would be negative. So, but then now, the gradient at A and at C, they would have the same magnitude, but they would differ with the signs. So it means that the velocity at C as well is also negative 4 meters per second, right? So, but for any point that are symmetrical across the turning point, so any mirror images across the turning point, mirror images of each other across the turning point, at these points the velocities would be the same, but they would just differ with direction, right? So now let's wipe that. All right, now we said that all right, can you hear me now?
Yes.
Yes, sir.
Yes, sir.
Yes.
All right, so now at B, the velocity is 0 meters per second, right? The mathematical explanation is that the gradient of this position time graph represents the velocity. What is the gradient here? The gradient at the turning point is 0, right? The gradient here at the turning point is 0. Because remember, gradient represents change, right? So here at B, the change is 0. The object is neither moving up nor down, right? So hence the gradient is 0. The yes, Ernest.
Okay, sir. So, you did mention or velocity can also be taken as the gradient. Am I right?
Yes.
So if we're considering the velocity as the gradient, and then we are that AB is a increasing gradient, right? And then C is the decreasing gradient, because we are the axis of symmetry is the mirror refraction. And get what I'm like the confusing part is if like velocity is the gradient, y is like the velocity for AB and BC the same, because we did mention when the object goes down, acceleration it's obviously not acceleration, man. The velocity is gonna increase because the object is speeding up. You understand what I'm trying to say? Like
The gradient, you are saying the gradients are the same in magnitude. Remember what is gradient?
gradient.
Gradient is the measure of the steepness, right?
Yes.
And the steepness does not care about the direction. So the gradients, and what I'm saying when I'm saying that the gradients are the same, I mean the magnitude. Because of now, look, if you were to look at this mountain, right, it's sloping up like that, right, and look at another mountain that is also like this, but then now it looks like this, right? So now, would you say that now the steepness of this mountain differs from the steepness of that mountain just because of now the directions are different? Because of now, if you look at this one, this is an increasing straight line graph like that, and this is a straight line graph like this, right? So the steepness is still the same, but then now the directions are different, right? It's just the same as at A and at C. At A, the steepness at A would be the same as the steepness at C, but then now the directions are different. This negative does not tell us how steep the graph is. It only tells us the direction of the steepness, but not how steep it is. How steep it is, you'll get it from the magnitude. That is why I'm saying that that is why I'm saying that at A and C, the objects were moving at the same speed. They are moving at the same speed. Let's put it that way. They are moving at the same speed,
Okay.
but in opposite directions, right? But in opposite directions. All right.
Yes,
so
sir.
so we all on the same page, right? So this topic now, in the tutoring program that I attended, I think they knew that this topic would be much easy to understand if we do calculus. Let me tell you a secret. The person who came with this topic and the person who came with calculus is the same person. Just that calculus, it's the maths around this topic. You guys get it? So it's the maths that is involved in this topic, but it's still the same thing. Remember, in maths, our variables is just x and y are known variables. But then in physics, we give those variables meaning and say that x is time, then y is position. You see, but it's still the same thing, right? If you were to do calculus, you would have a clear understanding of this topic. But then we won't stop just because you guys don't know calculus. We will continue with it. Yeah? But once you've done calculus, please come back to this topic now and, do it now with a mature mind, if I were to put it that way, right? Okay, so now let's pass. Yeah. Okay, now another thing is that the time it takes the object to travel from A to B is the same as the time it takes to travel from B to C, because remember we are plotting time on the x-axis, right? So the from here to here is equal to from here to there, right? You know that, I get. So if it takes 3 seconds, they said that this entire path, it took the object 6 seconds. So it means that this side, it took the object 3 seconds to move from A to B. It also took the object another 3 seconds to move from B to C, right? Do you all agree, guys?
Yes, sir.
Yes,
All
sir.
right. All right. So sometimes you might be given, you might be asked maybe to make a calculation using the points A and B, but you don't have the time it takes to travel from A to B, but then you are given the time it takes to travel from A to C. So to get the time it takes to travel from A to B, what you do is take this time and divide it by 2. So that's how they can actually manipulate you. So that's why it's always important to start by drawing the path that the object follows, then put in information before you attempt the question, right? So when I said that here, when I said that you need to choose 2 points that you're gonna be working with, so let's talk about that one now. So whenever you make a calculation, right? Let's say they say calculate the velocity at C. Maybe we didn't have it, right? So we're gonna say, okay, I can either use C and B to perform the calculation, or I can use C and A, the points C and A, to perform the calculation, right? So it means that because now the object started at A and it ended at C, so anything at A would be my initial and anything at C would be my final. Or if I'm using the points B and C, the velocities at B would be my initial velocities, and the velocities at C would be my final velocities, right? So that's what I mean when I say you need to choose 2 points. Or maybe they want you to calculate something here at B, maybe the height of B above the ground, right? So you can either use C and B, or you can use A and B. When I use A and B, anything at A, the velocities at A are my initials, and the velocities at B would be my finals, right? But when I use B and C, the velocities at B is initial, the velocity at C is final. What do you guys say?
Yes.
Yes, sir.
So always name your points using letters like this. Even if it means using numbers, you can simply say that this is 1, this is 2, this is 3. You can also do that. But I prefer letters. All right, so now let's take a look at now different scenarios, right? So projectiles, it's important to understand that projectiles can follow different paths, right? But then now this one, it's a full path, right? Full path of a projectile. Sometimes we can cut the problem if this part is not there, maybe started from B to C. So they tell you that an object has been dropped from a certain height. So the problem would be starting from here, then it ends here. That would be our the motion that the object follows, right? Or sometimes it can be thrown from here, then it gets to B. Then now when it was supposed to go back down, maybe they catch it somewhere there, right? So they can always cut it into pieces, bits and pieces, right? So it don't always be a full graph like this. Or sometimes it can be something like this, then continue down further, right? Maybe if an object was thrown from the top of a building, they throw it up. So when they throw it up, it's gonna move up, reach a maximum height, then start going down again, like that. You see that we can get different combinations of the graph, can get different combinations, but you need to be able to do that on your own, right? So now let's take a look at different scenarios. So this scenario number 1 here, they tell us that a boy drops an object from a height of 25 meters. So remember, what does drop mean? Means that V initial is 0 meters per second, or the velocity at the point where it was dropped, it's 0 meters per second. So I can name this point where it was dropped, name it point A, right? And when it hits the ground, I can name it point B, right? And they said that from A to B, it's 25 meters. That height is 25 meters. So now they say we should calculate the velocity at which the object hits the ground. Which velocity are they talking about? They're talking about the velocity at B, right? Where it hits the ground. So we are looking for this velocity here. We don't know what it is, right? So now let's take the points A and B, put in information that we have, right? So from A to B, right, I put in the information that I have. My V initial, remember, anything at A would be initial, then at B would be final. So V initial would be 0 meters per second. V final is what I'm looking for. But remember, I always have the acceleration is negative 9.8 meters per second. Then what else do I have? This 25 meters. From A to B is 25 meters. What can I do with it? But first things first, let's choose a direction. Up is positive, right? Remember, now this would be my change in Y, right? My displacement. The object from A to B, as you can see, the object was displaced downwards. Remember, displacement is a vector. We need to consider its direction. So from A to B, the object was displaced. Tell me, guys, the object was displaced down, right?
Downwards.
The object was displaced downwards, right? So now does this mean that my change in y is gonna be how much?
Negative
When I
20.
give negative 25 meters.
25.
Negative 25 meters, because the displacement, remember 25 is the distance, but then what the formulas use, they use change in x, change in y. It's my displacement, not distance. So when I present it, I should present it with its direction. So the object was displaced 25 meters down, right? Moving from A to B, the object moved down. So it means that it was displaced down, right? So it means that now it's negative. Why is it negative? Because we chose up as positive. Therefore, down would be negative. Then we're going to look for a formula with these 4 variables. Which one is that? Here are the formulas. I gave them to you. Choose which formula has 4 of these variables so that we can calculate
The second one.
The second one.
The second
right?
one.
The second one, Vf squared equals to Vi squared plus 2 acceleration change in y. Can we substitute now? Vf would then be 0 squared plus 2 acceleration, negative 9,8, change in y, negative 25, right? That's Vf squared. Then let's put that in our calculators. Vf squared is going to be 2 times 9,8 times 25, 490, right? Vf squared is 490. Now I'm going to teach you maths, right? I'm going to teach you maths now. When you have x squared is equals to 4, when you square root both sides, you need to put a plus or minus, right? I hope Bungingosi taught you this, if you guys are doing maths with Bungingosi. So now, right? So now our VF would then be plus or minus the square root of 490, right? The square root of 490 is 22,14, right? So VF is 22,14 meters per second. Are we taking the positive one or the negative one? At B, the object was moving down. So the velocity is downwards. So we're taking the negative one. Then we conclude and say, therefore, VF is 22,414 meters per second down. Yes, this is.
So like for direction, we like when we calculate for direction and get it must have a variable name. So for direction, okay. So like are we supposed to take like the last one, isn't the first one for direction, or like it mo kaya feletsa ko kae? Re tseela mathomo angere re tsaya mafelo.
Okay, the velocity that we were, the question should be the velocity that I was calculating now, it's at which point? This is the velocity in the calculator no, so the velocity amo which point?
Iliamo B.
Nilamo B, again. So when now using your mind, go B, object A, ya khona hala hore object A go B, ne ya go di.
A.
So ne ya ga
Ko class.
So direction, you take it based off your observation. What you are observing on the diagram, you see that at B, my direction is down. So the direction of the speed is the direction in which the object is moving, right? So therefore, it's down. Why would you see?
Okay. Yeah.
All right. As long as you this is like a happy. So here we have that the velocity, we're gonna add it, right? We now have the velocity at B, right? So the velocity at B is equals to negative 22,14 meters per second. Are we all on the same page, guys?
Yes,
Yes,
sir.
sir.
All right. So now let's wipe here and do the next question, right? Should I give you guys an opportunity to do this one? I think you can do it on your own. Follow the same steps. I'm gonna give you like 3 minutes. Max.
Should we do the second question?
Yes, number 2.
Okay, sir.
Guys, are you done?
Yes, sir.
Yes, sir.
Yes.
It was easy, né? How much did you get?
5,1 seconds.
5,
5,1 seconds.
so let's confirm, right? So obviously we only have 2 points here, A and B. So we are using the points A and B, right? So my V initial still 0 meters per second, right? My V final now, I have it is negative 22,14 meters per second. I also have the change in Y is negative 25. I also have the acceleration is negative 9,8. I'm looking for the change in time, right? So there are a lot of formulas that we can use now. We can either use, I usually advise people to not use a variable they calculated in the previous question to solve the next question if that's possible. For example, here we have an option to use a formula that either has change in Y or one that has VF. I would rather go with one that has VF because one that has change in Y, because VF it's a variable that I calculated myself and it might be wrong, right? But either way, we already know that it's correct. So we can also choose a formula that has VF. So we can go with VF equals to VI plus acceleration change in time. Because also, if you opt for this formula, this one, yeah, change in Y equals to VI change in time plus 1 over 2 acceleration change in time squared, you must be very good with your quadratic equations, and that's going to be strenuous as well. It's going to take a lot of time using quadratic formula, right? So rather we trust our answer here, plus also there's positive marking. Do you guys get it?
Yeah.
Yeah.
So
Yes.
that answer is gonna be wrong because I forgot to square the
time
at the end. So yeah, it's gonna be wrong.
Oh, okay. Yeah, so we will fix it.
Let me see.
So the VF negative 22,14, V initial 0, acceleration negative 9,8 multiplied by time. So time would then be negative 22,14 divided by negative 9,8. If you get a negative time, just know that your answer is wrong. Don't be in denial. 22,14 divided by 9,8. So that's 2,26. Did you guys get 2,26?
Yes.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Change in time equals to 2,26 seconds,
Yes.
right? So if you use this formula, you might get a slightly different answer, right? But it should not be far away from 2,26. No?
Oh, sorry,
Just
sir.
know.
So
Yes?
it's the same answer, sir.
Yeah,
You get the
it
same
is.
answer.
Yes, because I
Yeah.
squared the answer I got, but I squared root the answer I got, and then it gave me 2,26. The same answer actually.
All right, that's good. Yeah? But then I'm just saying that sometimes when you use these different formulas, they can give you different answers, especially this one. You see this one? Rather, even you can even scrape it out now because it usually gives different answers. I never used this formula. I never used it. And you might also never use it before. You might also never use it. Yeah. Just be aware that sometimes it does give us. If you take the memo, yeah, vertical projectile motion on the past papers, the markers, they work a lot there because different formulas, they always give different answers, and it's just a lot of work, right? So, but then let's move on. You guys can do this one now. Instead of me doing it for you, let me just give you 5 minutes to do it. Hello guys, are you done? Hello.
Yes.
Yes.
All right. So how much did you get? Type your answers for 1 and 2 on the public chat. Just write 1, then write the answer, then space 2, then write the answer. I want to see if you guys are getting the same answer on the public chat. Yeah, you guys are getting different answers. You are getting 240,1, 240,1. I can see 240,1. All right. Let's do it together, guys. Yeah, let's do it together. Remember, guys, height and distance. Height and distance, they are the same thing. Height is just the vertical distance. So whenever you calculate height, it does not need you to show the direction. But then on the formula, there's no formula to calculate height. You would be calculating the displacement. But when you give off your final answer, you give it with no direction, yeah? Because it's height. So, like I said, sometimes the displacement of an object and the distance it traveled, they're the same, right? So they're the same in magnitude. But when you're gonna give off the height, it should not have direction. But I'm just glad that you guys are giving off the directions down to show that when you calculated, you got negatives. All right, so we're gonna take up as positive, right? So the object here was thrown at point A. It was thrown at a velocity of 5 meters per second. It was thrown down, right? So it was thrown downwards at 5 meters per second. So the initial velocity should be what? Positive or negative?
Negative.
Negative.
Negative 5 meters per second, right? That's the initial velocity because the object was thrown down. Then it hits the ground there at point B, right? They said that it takes 7 seconds to move from A to B, right? So time is 7 seconds. Did you guys see this one? The time that it takes to travel from A to B is 7, right? Then now let's put in information properly. We're gonna use the points A and B. We have the initial velocity as -5. We have the time as 7 seconds. We also have the acceleration as -9,8 meters per second squared, right? What does the first question want? Height. So to calculate the height, it will actually be the same as the displacement of the object, because if the object moved in this direction, so it means that also the displacement would also be in that direction, right? So it's also going to be this height. The displacement is going to be this height. So can you see, like I told you, that sometimes the displacement of the object is the same as the height if the object followed the same path as the displacement, then the height and the displacement would be the distance traveled and the displacement would be the same. So if I calculate the displacement here, I would get the height. So change in y is what we are looking for. So a formula with change in y, v initial, change in time and acceleration, it's this one. Change in y is v initial, change in time plus 1/2, acceleration change in time squared. So change in y would then be -5. The time is 7 seconds plus half, acceleration -9,8. The time is still 7 seconds squared. Then let's put this in our calculators, guys. Sorry. -5 into 7 plus half into -9,8 into 7, then squared. I'm getting this answer, -275,1. Who got this answer?
Me, sir.
Me.
Negative
Sir,
275. Yes.
so you know why some of us got like 40,1?
Mm-hmm.
It's because like we thought if an object is dropped from like okay, just in general, if an object is dropped, means the velocity is equals to zero.
No, but then here they did not say it was dropped. They said that it was thrown at a
Oh,
velocity of 5. Right? So they gave it an initial velocity by throwing it. But if you drop it without throwing it, then its initial velocity would be 0. But in this case, it was thrown. Literally, it was thrown. So its initial velocity can't be 0. Do you guys get it now? Those of you
yes,
that got 240.
yes,
Yes,
okay.
sir. Get it now.
All right. So in this case, it's negative because it was the initial velocity is negative because it was thrown downwards. Sometimes it can be thrown up. So if it's thrown up, we would expect the initial velocity to be positive. The statement will literally say that it was thrown up at this velocity. Yeah. All right. So negative 275, 1 meters, right? So it's negative. This value is negative because the formula calculates displacement, not distance. Then we have to therefore conclude and say, therefore, height of at which the ball was thrown is actually 275,1 meters. Do you guys see what I mean?
Yes.
Yes, sir.
All right. So we know that the change in y, or let me write h, height, is 271,5 meters. All right. So now can we move on to question 2? Calculate the velocity at which the ball hits the ground. So look, I'm looking for VF, right? So remember I told you that sometimes it's very good to use a variable that you didn't calculate. So instead of using that change in y, I can still use V change in time, acceleration, and VF, which is this formula, right, to calculate VF without using the change in y that I just calculated now. But if you do use it, you'd still get the same answer. Yeah. So then VF is equals to VI plus acceleration change in time. VF should be negative, right? We are already expecting VF to be negative because at B, the ball was moving down when it hits the ground, right? So if you get a positive answer, you already know that it's wrong. So VF would be negative 5 plus acceleration, which is negative 9,8, time, which is 7 seconds. Negative 5 plus negative 9,8. I'm also teaching you how to substitute on your calculators. Can you see, guys? Use brackets to substitute on your calculators. So negative 73,6. Negative 73,6 meters per second. Then when we give off our final answer, would be 73,6 meters per second downwards. Do you guys get it? Hello?
Yes, sir.
Yes.
Yes, sir.
Okay, I see some of you guys did get the both answers correct. I can see this one got 76,60. That's correct as well. Yeah. So no, yeah. All right, let's pass. Yeah. So now let's take a look at this scenario. Guys, I'm giving you, can I give you this scenario because like we are 2 hours in now. Can I give you these questions as homework? Then we will correct them tomorrow.
Yes, sir.
Yes, sir.
Yes.
Yes,
So I'll say,
please. Yes, please. Yo.
Please,
you are tired.
tired.
Yo,
Yeah, very
I kid 16 I
2
can
hours in.
breaking yana. Don't overwork yourself.
Mm.
That's
Now
homework.
we were
So, sir,
almost
are you
done.
gonna send them on the group or are you?
Yeah, I'm gonna send them on the group. I'm gonna send them
Okay,
on the
thank
group.
you, sir.
We were almost done actually with session 1. We didn't finish session 1. Imagine we were supposed to cover everything, but I guess we spend a lot of time explaining, which is not a bad thing. Though. Remember, time is on
Yes,
our
which is
side.
not a bad thing.
I know, guys. I really enjoyed today's session, mainly because I love this topic. Hey, with momentum and impulse, I was learning a new things while I was teaching. Hey, that topic, that topic, but it's fine. It's fine. See you guys tomorrow. Then enjoy the rest of your day.
Sir, before you
Tomorrow, sir.
leave,
Good
may I
day.
ask a question?
Yes, yes, yes.
On the concept of speed versus velocity. Say,
Mm-hmm.
why do we say average velocity or average speed instead of we calling it velocity or speed?
Okay, because remember that there is instantaneous speed and average speed. I'm glad that you brought this question up. So let's go to these problems that we are dealing with, right? So let's take a look at this one as an example. You see that the speed is not the same, right? It's changing, right? It's changing at different points. There are different values of the velocity, right? Or the speed, right? So now, the formula speed equals to distance over time. It calculates the average. Does not it does not calculate the speed at a certain point, right? But then these equations of motion, right? These equations of motion, they calculate the value of the speed or velocity at a particular point, right? So basically, like average speed, it just shows you on average how fast you were traveling. It does not mean that throughout the entire journey you were traveling at that speed. Does it make, as you can see here, the values of the velocity changes with different points. But then now, if I were to say that, okay, on average, the object was moving this fast, I need to give a single value, I would use this formula, right? And also, besides you calculating the average speed using this formula, you can also calculate the speed if then now the acceleration is 0. Maybe the object was moving at a constant speed. You can also use this formula. Yeah?
So it has nothing. Say,
yes.
It has nothing to do with adding the minimum speed and the final and then divide it by 2.
So that would be the mean speed, not the average speed. No, I'm using the different words. That would be the median speed, not the mean. Because remember, statistics, what is average? Average is adding all of them, then dividing by how many they are. That would be the average. How would you do that?
Truly speaking, say I'm confused about these things. Average velocity to average speed. Ish, I'm confused.
Look, yeah? If let's say you have numbers 10, 15, 17, 12, right? What is average? What is the average value here? If let's say the object was moving at this speed, that speed, that speed, and that speed, right? Then the average would actually be adding these values together, right? 10 plus 15 plus 17 plus 12. Then you divide it by the number of numbers we have here. It's 1, 2, 3, 4. Divide by 4. That's what average means. But then now with velocity, with like VPM or motion, the object changes speed at every point, at every little point. So it has so many speeds, right? So even after a split second, the object has a different speed. So it's impossible for us to calculate the average using this method. Rather, we use this method of just saying, okay, the speed is just saying the distance over the time, right? Just taking the distance, dividing it by the time, right? But then the idea of something being average, this is how I can explain it to you, right? On average, this is how fast you were moving, right? So just like in class, when they say they want the average mark, they don't take the maximum plus the minimum divide by 2. They add all of them, then they divide by the number of students in class, just to see on average how you guys are performing, right? So same thing, average speed, it just shows you on average how fast you are moving. I don't know if that makes sense or if it answers your question, but we can always try find other ways to explain it, ne? But for now, that's how I can explain it. If you still don't get it, I will try find other ways to explain it. But then just know that an average speed is a constant speed, ne? It's a constant speed, right? So yeah. Let's conclude
Thanks,
the
sir.
meeting.
Thank you so much.
Let's conclude the meeting. See you tomorrow and enjoy the rest of your day. Bye.
Bye, sir. Have a
Bye.
good day.